So throw your name on here. First thing that we're looking at on here is what we are calling our parent functions. So parent functions are the original functions that we start with. We have to have something to transform. So we've got three functions that we're looking at. I labeled them back in 4.4 just so you could see them, and then we've been using this shape in 4.5 as well. Our three functions are a linear function, which is a straight line, a quadratic function, which is U-shaped, and an absolute value function, which is V-shaped. Linear functions are just a straight line, so all the points go in a straight line. With a quadratic function, what you need to know about the points is that you start in the middle, and then from there you go up one, out one on each side, and then up another 3, out 1. So I'm going to write that down right here, and you'll see why in a second once we start graphing them. So up 1, out 1, up 3, out 1. Because we're going to have to graph these here momentarily. So that's the pattern that it always is. So you start in the middle, up 1, out 1, up 3, out 1. And it makes that U shape. Okay, absolute value functions are V-shaped, and their pattern's a lot easier because it's just up 1, out 1, and then up 1, out 1 again. So let's write that down. Up 1, out 1, up 1, out 1. Okay, so we've got these three parent functions. These parent functions can be transformed or moved. For today, we will be transforming quadratic. I'm going to abbreviate that just to quad. And absolute value. I'm going to abbreviate that too. I don't know why I made these blanks so small. Functions. The reason why we're only doing those two is because linear functions, we already learned how to graph in Unit 2. And transforming a linear function is never the practical way to do it. It's always going to be more practical to just graph it in slope-intercept form. Okay, one thing that I forgot to mention before we move on to our next thing is the equations of these functions. So a quadratic function is x squared. So it's f of x equals x squared. And absolute value is absolute value of x. So these absolute value bars go around the x. That's absolute value is the distance from 0. So the distance that 1 is from 0 is 1. The distance that negative 1 is from 0 is also 1. That's why it makes that symmetrical V shape. Okay. Any questions right now? Okay. Moving down to here, we are going to learn the 4 rules. We are only moving our graphs up, down, left, and right today. When you guys get to Algebra 2 or Geometry next year, Algebra 2 the next year, you will also stretch your graphs to make them taller and skinnier or shorter and wider, and you can also flip them around. Right now, we're just focusing on keeping the graph the exact same shape, moving it left, right, up, and down. So if you add inside your function, that is going to move your graph to the left. An example of what that's going to look like is this. F of x equals, in parentheses, put down x plus 5. We're just using 5 as an example. Close your parentheses, and then put your square after. Okay. For an absolute value function, what that would look like would be this. F of x equals absolute value of x plus 5. Okay, if you subtract inside your function, sorry, I forgot what I had written down. If you subtract inside your function, that is going to move us to the right. So that's going to look the exact same, except for instead of plus 5 inside, we're going to put minus 5 inside. So to subtract would look like this. Or subtract inside, sorry. F of x equals x minus 5 squared, or f of x equals absolute value of x minus 5. So when we say inside a function, we are referring to either being inside what's being squared or inside the absolute value sides. These operations will move us left or right. I'm using the plus 5 and minus 5 as an example, but this would move us left 5 and right 5. The other thing that we can do is we can add outside or subtract outside our function. If we add outside of our function, that is going to move us up. What that's going to look like is f of x equals x squared. So the squared happens, and then plus 5. For an absolute value function, it would look like this. F of x equals the absolute value of x, and then the plus 5. So the key of today is looking at the difference between inside versus outside. And the reason why inside versus outside does two different things is it's whether or not you're adding to the phi or adding to the x, or you're adding to the entire function before or after any operations happen. Okay, and then the last thing to fill out this little table is how we move down. We move down by subtracting outside. So what that looks like is f of x equals x squared minus 5, or f of x equals the absolute value of x minus 5. All right, any questions on this table? We took a little bit of time to make this. This table is the same as the table we're going to use tomorrow, so we won't have to refill it out tomorrow. Any questions so far? Okay, so you guys are going to do two things, basically. You're going to identify which parent function you're using, and then you're going to identify what transformation happened. Then you graph the new parent function. That's all going to be on the back here. We've got either 4 or 6. There's 6 examples because this is the first time we've seen this. So identify each parent function, then identify the transformations, and graph the transformed function. So this first one here that we've got f of x equals x squared plus 3. So to identify the parent functions, we've only got 2 options. It's x squared or the absolute value of x. This one is x squared. Then we need to identify the transformation. So we look and see what operation or operations have happened. We are adding 3 here. Is that inside or outside? Outside, because it's not inside what's being squared. So adding outside tells us to move up. And you've got that table that you can use. So that tells me I am going to move up 3. The 3 comes because it's plus 3. Okay, so then we just graph the same U-shaped graph, that same x squared graph, but we're going to move it up 3, and that's it. So instead of our graph starting at 0, 0, we're going to move our pin up 3, put a dot there. And then to make that U-shaped graph, from that point, we're going to go up 1, out 1 on each side. And then we're going to go up 3, out 1 from each of those. Up another 3, out 1, up another 3, out 1. Should always make the same shaped graph. Once you get your dots on there, you can connect it in a U shape. We do want you to graph your dots, though, because we want that specific shape. We don't want you to just throw a U on the graph anywhere. Okay. Any questions about that first one? Okay. The next one, we have to identify our parent function. In this one, our parent function is the absolute value of x. So that's our V-shape one. So we just ignore the -2 and what's left is our parent function. Okay, then we've got to look at the operations that are happening. So this one, we are subtracting inside. Because the -2 is inside the absolute value signs, that means subtract inside. So if we subtract inside, which direction did that send us? So flip back, look at your table if you need to. I'll flip back, look at my table. Where does subtracting inside move us? Right. So subtract inside moves us to the right. So we are going to move right 2. Okay, so then instead of our graph starting at 0, 0, we take our pin, move it right 2, put a dot there. And then to make this lovely V-shaped graph, we go up 1, out 1 on each side. And we do it twice each way, sorry. So go up 1, out 1, and then up another 1, out 1. I did the 2 on the right and then the 2 on the left. When you connect these, connect them into a V shape, not a U shape. All right. Any questions about those first 2 examples? Okay. What's different about the third one? What is different about this one than the 2 we've seen so far? There's 2 transformations. So we've got this +5 here and this +3. So we have something happening inside and something happening outside. What that's going to mean is we are going to move left or right, and we're going to move up or down. You will always move left or right and up or down. You will never move both left and right because that would just cancel itself out. You will never move both up and down because that would just cancel itself out. So parent function is the same. Parent function on this one is x squared. And then we are adding inside here. Adding this +5 inside moves us left. So on my first blank, I'm going to write L5. L for left. And then the plus 3 outside tells me to move up. So I move left and up. Oh, just kidding. Again, move left up 3. I was like, how am I going to move up 5 and still have space in my graph? Sorry. Up 3. There we go. So left 5, up 3. So what that's going to look like is we're going to take our pencil, start it at 0, 0. You move left 5 and up 3, put a dot there. Only put one starting point. Don't put the one that's left, just left 5. And then from there, we do our U-shaped graph. So our U-shaped graph, we go up 1, out 1. And then from each of those, we go up 3, out 1. And it fits perfectly there. Okay. Any questions right now? All right. I would like to take a second. I feel like I didn't do the graphs justice when I explained them. So flip back to the front. I want to make sure we understand why the parent functions are shaped the way they're shaped. So the reason why the quadratic is shaped the way it's shaped is that when we plug in the x value, this is the y value we would get out. So when we plug in 0, 0 squared is 0. When we plug in 1, 1 squared is 1. So that's why we go over 1, up 1. When we plug in 2, 2 squared is 4. So that's why we jump all the way up to 4 here. Then on the left side, negative 1 squared would be negative 1 times negative 1. That's why it's also positive 1. Negative 2 squared is negative 2 times negative 2. That's why it's positive 4. Okay? So that's why the quadratic is shaped like that. The absolute value is shaped like this because 0, the absolute value of 0 means the distance from 0. Distance from 0 is 0. Distance from 1 and negative 1 are both 1. Distance from 2 and negative 2 to 0 are both 2. Just wanted to mention that. I felt like I glossed over that too quickly. All right, back to the back. Let's zoom through these last 3 so you guys have some time to work on your assignment. Okay, so absolute value of x plus 4 minus 3. Parent function is absolute value of x. I just said that. Okay, I am adding 4 inside. Which direction does adding inside move me? Left. So I'm moving left 4. And then I am subtracting outside. What direction does subtracting outside move me? Down. So the outside ones move the way you think they're going to. The inside ones move the opposite way that you think they're going to. So we're going left 4, down 3. So we go left 4, down 3, put a dot. And then I can go ahead and make my V-shaped graph from there. Okay, next one, x minus 3 squared plus 1. My parent function is x squared. Subtracting inside. This one's the exact opposite because now I'm subtracting inside. So subtracting inside moves me right. So right 3. And then adding outside moves me up. So right 3, up 1. Let's zoom in a little bit to this. So right 3, up 1. I've got to make that U-shaped graph. It looks like this. We go up 1, out 1 on each side. And then up 3, out 1 from each of those. Okay. Any questions on that one? Okay. Last one then. What is my parent function? Absolute value. Okay. -4 inside tells me to move right. So I'm going to move right 4. And then -2 outside tells me to move down. So I'm going to move down 2. So right 4, down 2. Right 4, down 2. Put a dot there. And then it's my V-shaped graph, so I just go up 1, out 1 on each side. And I do that twice. Hey, any questions right now? Okay, I know that took a little while. Because that took a little while today, it's going to make 4.7 go by super breezy. I'm going to stop the video.